Good morning to everyone. This is Sumitra from CSE. Today's topic is matter waves and its properties. Introduction to matter waves. Matter waves refers to the concept of all the matter exhibits both waves like particle like properties and concepts central and to the quantum mechanics. The particle wave duality is the idea that both light and the matter, such as electrons and protons, exhibits both waves like and particle like behavior. It is proposed by Louis de Broglie in 1924. Matter waves are used to describe the behavior of particles at microscopic scales such as electrons in an atom. De Broglie's hypothesis. Louis de Broglie postulated at that particles such as electrons have wave properties characterized by an wavelength. The wavelength of matter waves is inversely proportional to the quantum of the particle. The relationship is expressed by the de Broglie's equations lambda is equals to h by p, where lambda is the wavelength, h is the Planck constant, and p is the momentum. And it is can be written as lambda equals to h by mv, where lambda equals to wavelength, v equals to velocity, m equals to mass, h equals to Planck constant. The wave particle durability. The wave particle durability. This is the principle that every particle or quantum exhibits both particles like and wave like behavior. For light, this durability was first observed in the photoelectric effect and interference patterns. Similarly, matter waves are confined experimentally for the particles like electrons to the phenomena like diffraction similar to the light waves. The durability challenges classical physics as particles are traditionally seen as distinct whereas waves are continuous. Electron diffraction. The Ravijan-Gemner experiment 1927 provided experimental proof of the wave nature of the electron. In this experiment, electrons are fired at an crystal and the resulting diffraction pattern similar to that observed with the light waves as analyzed. These diffraction patterns proved that electrons exhibit wave-like behavior, supporting de Broglie's hypothesis and establishing the reality of the matter waves. The diffraction pattern often direct the manifestation of the interference of the electron waves. Properties of matter waves. Wavelength. Matter waves has a wavelength associated with the particle momentum defined by the de Broglie's relation. Frequency. The frequency of the wave is related to the energy of the particles by E is equal to hf. E equals to hfe. Hfe is equals to where E is the energy and the f is the frequency. Velocity. The phase velocity and group velocity are two key concepts. Phase key. The speed at which the phase of the wave moves. Group velocity. The speed at which the particle moves usually corresponds to the particle's velocity. Heisenberg uncertainty principle. The Heisenberg uncertainty principle arises from the wave nature of the particle. It states that you cannot simultaneously know the exact position and the momentum of the particle. Mathematically, delta x dot delta p greater than or equals to h4 pi by delta. This is the consequences of the wave nature of the particle. A particle's position is spread out due to the wave-like behavior, making measurement impossible. The uncertainty principle introduces a fundamental limit to the perception of the measurement in quantum mechanics. The equation is the cornerstone of an quantum mechanics governing the evolution of an matter waves. Time independence equation. H is the Hamilton operation, total energy operation. The wave function provides the probability of finding a particle in a particular region of an space, insulating the problematic nature of the quantum mechanics. Application of matter waves. Electron microscopy. The wave nature of the electron allows electron microscopes to achieve such much higher resolutions than optical microscopes because the wavelength of the electrons is such smaller than that of visible light. Quantum tunneling. In quantum tunneling, particles can pass through potential barriers that may classically should not be able to. This the direct consequences of their wave-like properties, where the particles' wave functions are extinct into regions it classically should not have access to. Semiconductors. Understanding the wave nature of the electron is a key to the design of electric device like transistors and diodes, which relays a quantum mechanical effects like tunneling. Conclusion. Matter waves described by the de Broglie's hypothesis plays a crucial role in understanding quantum mechanics and the behavior of the particles at microscopic scales. The wave particles duality of an matter is a cornerstone of an quantum theory, challenging classical concepts and enabling groundbreaking technology. Applications such as electron microscopy and quantum tunneling highlights the importance of matter waves in real world physics and technology. Matter waves continue to be key element of an modern research in the fields such as quantum computing, nanotechnology, and material science. Thank you.